All right, we come now in Chapter 8 down to the last section we're going to do is 8.5, and the last concept we're going to cover is this whole concept of systems of inequalities. What happens if you have inequalities and you're trying to have two or three inequalities and all the stuff that we covered so far. So let's go for it. All right, inequality, of course, is a graph that has a less than symbol, greater than symbol, greater than or equal to, or less than or equal to. All right, so let's do a quick intro first to this, and then we'll go for it here. Just a quick, easy example, something that you guys have probably done numerous times in your math careers. Here it is. We're going to graph 3x plus y is less than 6, and just to tell you here, there really are two different methods to do these. Your book chooses a certain method. I'm going to follow the same as what the book does, and so we'll go for it. So what the book does is, the first thing is it does it by something called test points. So what we do is we make this guy equal to, as opposed to an inequality, we make it to be an equality, an equal sign. All right, because of that, now we have all the tools necessary for us that we have done with graphing. So what we do is we subtract 3x from both sides, gives you a negative 3x plus 6. All right, before we start graphing, what we must realize is this whole concept of dashed lines or solid lines. And I think you know this from your previous math classes here. If you have a less than symbol or a greater than symbol, what you have is you have dashed lines, which means the answer is actually not on a line. The answer is only going to be as part of the shade. If you have a less than or equal to or greater than or equal to, that little equal to part means that you want the stuff that's on the line as well as the shade. So it just changes up the problem depending on what you're doing, depending on what the word problem is or the application problem is. All right, let's go for it here. I think we know how to graph y equals negative 3x plus 6. Start off at 6. The slope is negative 3, so we're going to go down 3. 1, 2, 3. 1 to the right. That gets me the second dot. And can we keep on going? Keep on doing this? Absolutely. We can go another 1, 2, 3 over 1. 1, 2, 3 over 1. We can keep on doing this for a long time. All right. And then we also know that we can actually go the other way as well. Instead of down 3, 1 to the right, you could also go up 3, 1 to the left. And that, notice that little dot right there, that's still also going to be part of this line. So just so you know, for later on. All right. But what do we have here? We have a dashed line on our hands because the initial sign for us was a less than symbol. So it was this symbol right here, therefore dashed line. All right, and this is called the test point method because we're going to pick a test point. And the easiest test point to pick is 0, 0. Now if the line goes through 0, 0, you got to pick something else. You got to pick something on here that's not right on this line. So pick something in this area, over here, but 0, 0 is the easiest one to plug in because things cancel when you plug in zeros. And so let's go for it here. There's my little 0 dot. And if you want to think about this, this is what's happening here. If you think of an analogy like with scissors, let's say we cut the sheet of paper into two different halves. Our question really is, do we keep the right half, or do we keep the left half of this sheet of paper? And we do it by this thing called test points. And what we want to do is we want to figure out where's the true side and where's the false side. So if you're over here and you pick a test point, it's true, that means we're going to take the side with the test point and cite it. But if you're over here and the test point turns out to be false, what we're going to do is we're just going to shade the other side of the test point, because these sides are either true or false. If one is true, you know the other one has to be false, and vice versa. If this is false, you know this side has to be true, and we only want to take the true side. So let's go for it. Test point 0, 0, 3 times 0 plus 0. The whole entire left hand side is just going to be 0 anyways. Most students just put a 0 and we're done. So 0 is less than 6. Is that true or false? That is true. It's that little sheet right there. And because of that, what we'll do is we're going to shade in that right there. All right, and if you want to sort of see a step-by-step process, what we just did, step 1 was to make it an equal sign. Step 2 was to figure out if it's solid or dashed line and sketch that. And then you divide the plane into 2 different pieces. So we pick a test point and then we shade in the true side there. All right, and then there's the 2 conditions here. If the test point satisfies the inequality, we shade the one with the test point inside it. If the test point does not satisfy, then we shade the exact opposite side of the line that does not have that test point inside it. All right, let's go with it. Let's try 2 more just to sort of get our feet wet, and then we'll jump to systems here. So can you graph this one here? If you want to go ahead of me, that's perfectly fine. Go for it. And then we'll go from there. So I'm going to have to turn this into an equal sign here. In fact, it's actually all ready for graphing. This is already good to go. This is y equals mx plus b. So we start off at 4. Don't forget the little dashed line and solid line. For this one, it's going to be a solid line for us this time. All right, let's go for it here. So we have begin at 4, and then we have a slope that's -2 over 1 technically. So we can go down 2, 1 to the right, down 2, 1 to the right, and you can keep on doing this. Sometimes you do want to do this, especially when you're doing systems of inequalities, because you want to get this perfect line and you want to know where the lines intersect. So sometimes you want to just keep on going all the way through. All right, as stated in the previous problem as well, instead of going down 2, 1 to the right, you can go up 2, 1 to the left. Notice that this line falls right in line with all the other dots, or this dot falls in line with the other dots. Up 2, 1 to the left, up 2, 1 to the left. There it is, and all the dots line up perfectly. So let's go for it here. Solid line, put arrows at the end, and here it is. We got to do that test point again. Easiest test point to use is 0, 0. Can we use it? Absolutely, because the line itself doesn't go through 0, 0. So can't use any of the points that we just graphed. Not those. You got to pick something else that's not on the line itself. All right, so 0, 0 is very convenient. This time, we got to plug in the 0 for the y value first, and then the x value comes in plus 4, or probably you guys would probably just write it like this as a test point. Right, you know that -2 times 0 is going to be 0, so you know that whole entire right-hand side is going to cancel, leaving us with that 4 there. So 0 less than or equal to 4, that is true. All right, since that is true, we're going to shade the area with the dot inside it, or shade the area with the test point. All right, true and shade. All right, and one more. This one, why it's a little different here. Notice the x's and y's are both on one side of the inequality, then your constant term on the other. On the previous problem, it was already solved for y, so we graphed it using y equals mx plus b. This one, what we normally do is we use the intercept method. Now the intercept method, remember, is this whole concept of just putting in a 0 for the x value, putting in a 0 for the y value, and calculating things here. So if the x becomes a 0, and this turns into an equality, question is, what's the y value have to be, or what's the y coordinate have to be? And it's 9. So this is just a different method of graphing as opposed to practice problem number 2, and actually practice problem number 1 we used y equals mx plus b. Here, using the graphing method, or sorry, the intercept method, plug a 0 for the y value this time, and you can see how fast this method is as well. You got yourself 9 for the x value. Based upon these 2 points, we're going to graph our lines. So 0, 9 would be 0 sideways, 9 up. That's the first point that we got. The second point is 9 to the right, 0 up or down. That's the second point that we got. At this point, you do want to get yourself a, if you're doing it on a sheet of paper, you want to get yourself some kind of straight surface that you can draw a straight line here. All right, if you're doing it or if you're doing an online homework assignment, then they usually have a straight line set up for you. All right, solid or dashed? That's what I'm looking for. Solid or dashed? I think that is a dashed line, and we connect those guys down. Arrows at the ends, and we got to pick another test point here. So let's go with test pointing 0, 0. And again, the whole entire right-hand side is going to go away because it'll be 0 plus 0. If you want to write down all the work for it, that's fine, but really, that's what you're really testing. So is 0 greater than 9? I don't think so. So that's a false statement. It does not fit the inequality, so therefore what we're going to do is we're going to shade the area that does not have the dot, or so there it is. All right, so now let's move on to systems of inequalities here. All right, not much different to do. We are going to pretty much just do or graph the same thing, just do it twice. That's all. That's kind of what we have here. All right, we do have an option here of either going this intercept method that we did for practice problem number 3, or doing the y equals mx plus b, or the slope intercept method like we did for practice problems 1 and 2. And so I sort of have to decide which way do I want to go about doing it. I think the y equals mx plus b is a better method because you get straighter lines. Because with the intercept method, you pretty much have one dot along the y-axis, one dot along the x-axis, and sometimes that is just not enough. But all yours, you could do it a different way, that's fine. You'll still end up with the same answers as long as both of us do it correctly. So let's go for it. All right, so looking at the first one here, changing that to an equal sign and solving it for y. So subtract 3x from both sides, divide through by a negative, or just change the signs on each one of those. So negative y becomes positive y, negative 3x, positive 3x, and plus 3 makes minus 3. So that one is set up for graphing. I'm ready to go with that one. And then the other one here, x minus y greater than or equal to 1 makes now x minus y equals 1. All right, same thing here. Move the x over, makes a negative x plus 1. Change all the signs, and makes it y is equal to positive x minus 1. I think we are ready for graphing. All right, here's my little graph sheet of paper. Here's the two things from the previous slide. And so let's go for it here. So this guy has to give me a slope. That slope technically is 3 over 1. So I start off at negative 3. I go up 3. So 1, 2, 3, and 1 over. 1, 2, 3, 1 over. 2, 3, 1 over. 1, 2, 3, 1 over. All right, and that is pretty good. Again, if you want to go down here, down 1, 2, 3, and over to the left, that would work too. That's fine. Again, you're just going to get this nice straight line across here. You know exactly where your points of contact are with the coordinates, with the integer coordinates. And so let's go for it here. So I think it is a dashed line. Look back real quick here on the previous slide just to make sure. Yeah, it's a dashed line. Arrows at the end, and let's do a little test point here. So the test point has to go back to the original inequality that we had. The original inequality was 3x minus y greater than 3. So we're going to plug in 3 times 0. Let me rewrite it here so I know exactly what I'm plugging into here. That's what I'm plugging into. And the whole entire left-hand side becomes 0. We're comparing 0 to 3 and 0 greater than 3. I don't think so. All right, with that, that is a false statement, so we shade towards the right-hand side of this particular line. All right, then let's go on to the next one. Y equals x minus 1. The slope here should be a 1 over 1. And then we start off, looks like our first point is at negative 1. So let's go for negative 1 here. We're going to go up 1 over 1. Ooh, I see that right there. There's my two dots. They overlapped each other. Okay, if that is the case, I pretty much found what I'm looking for. I found the exact corner where they intersect. Now I can go up 1 over 1 a few more times if I really like. But really, I'm not going to do what I did for the red graph. I'm not going to go all the way through. I'm going to just figure out where would this graph be if I went all the way over here just to make a straight line. And this time it's a solid line. And then we're also going to use a test point again. All right, now for the test point. Again, I'm still going to use 0, 0, still a good one to use. The graph itself does not go through 0, 0. That's cool there. And back to the original equation here, or inequality, it was x minus y greater than or equal to 1. And so look at the previous slide if you need to here. I'm just going to say 0 for the whole entire left-hand side, greater than or equal to 1. And that is also a false statement. I got F for false. Just being a little lazy here. All right, if that is the case, we're going to shade away from the 0, 0 marker. And what we have here is this little yellow shade that happens here. So now the question is this, because this is a system, a system means it is true for both lines. So we can say for all the lines here. And so we got to think about, okay, which one is the shade that's true for both of them? Well, you can kind of see there's kind of like a blue shade, there's a yellow shade, there's this sort of like a greenish sort of shade. That's the one that we want. That's the one we're saying, that's the one that's true for both. All right, I'm going to shade in that pretty much a little darker. That's what I want to do right there. I want to shade in that darker, and then a lot darker, then you know exactly what it is. All right, and then a lot of times what we do is we erase the other shades as well. So if you're looking at a multiple choice on the test or something like that, it's going to be looking something like this. You'll have just that little extra shade that's all by itself right there, and the others are all erased. So that little corner there is the final answer. All right, and now we move on now with a little bit more sophisticated problem here. Practice problem number 5 says graph this. That's a inequality of 3. Or we should say a system of 3 inequalities. That's what we got. And we got to do something else. We got to label the corners here. So at this point we do want to make sure that we go and put in straight lines into this as we do this here. All right, so let's go for it here. Again, what I like to do is solve each of these guys for y. Once I have that, then I'm going to graph each of those equations and then see where the overlap is. So first inequality, there it is, changing it to an equality. And we are going to subtract the 2x from both sides, divide by 3 everywhere, and we get an answer of, ooh, that's not too cool, especially that one at the end over here. That 3 does not go into 16 evenly. It goes into it 5 1/3 times. Ooh, okay, we'll see how that works. All right, the other 2 inequalities are a lot easier there because everything turns out to be integers there. So subtract 4x from both sides, gets you negative 4x plus 16. Divide by 2. And how about a negative 2x plus 8? All right, and the other side, let's see, 2x minus y equals 8. Subtract the 2. x from both sides, you still have the little negative y on the left-hand side. So let's just change all the signs on each of the terms. Voila. So you need to pause this in order to catch up with me. That's cool. If not, let's keep on going here. So these are my three equations that I'm going to graph. Let's just check. Are they solid lines, dashed lines? What are they going to be? So it looks like the first one here is going to be a dashed line for the first one, solid line for the second one, and solid line for the third one. Okay, I'm ready, set then. My little graph. All right, and the three equalities that I have set up. And so we got to figure out where in the world is 5 1/3. So along the y-axis, 5 1/3 is going to be about right there where that little red dash is. What we also want to do is we want to now go down. We're going to down 2 units from this dash. So we're at 5 1/3. We're going to go down to 4 1/3, 3 1/3, and then we're going to cut across 1, 2, 3. So notice we're still off a little bit. We're still off by a third here. So we're going to keep on going. So down 1, 2. So that's going to be 1 1/3. Cut across 3. Down 2. Cut across 3. All right, we also want to go backwards as well, right? Because this one, so from this 5 1/3, we're going to go now up and cut across 3. Up 1, 2, 1, 2, 3. So there it is, and that is, I believe, is a dashed line on our hands. The first one is a dashed line. So let's connect those guys there. All right, with that, got to do this little test point. Remember, the test point goes back to the original inequality here. So the original equality is 2x plus 3y less than 16. What we do is we just say, look, the whole entire left-hand side will be 0. We're comparing it to 16, and that is true. So we're going to have a big old shade towards the 0, 0 and beyond. All right, let's do the next one here. So negative 2x plus 8. That means we'll start off at 8, this one, and we're going to go down 2, 1 to the right, down 2, 1 to the right, and there it is. Looks like it hit right at a certain spot right there. Down 2, 1 to the right, and now it's sort of in that shaded area there. Again, I still want to include all these points for the next one because I'm not sure what the third one is going to intersect with the second one here. That's what I'm curious about here. So I want to make as many dots as possible. I want to make as straight of a line as possible. All right, this line also is a solid line, so let's bring it down, put 2 arrows at the end. And so I'm going to use 0, 0 again, since I can. All right, second inequality is 4x plus 2y greater than or equal to 16. I'm going to punch it in. That means it's a 0 on the left. Greater than or equal to 16 is my test, and that is false. So in this case, I'm going to shade away from my 0, 0 point. All right, and then again, we got to think of where's the overlap here. Where's the overlap that we see? It's right here. It's this little extra green little piece here. So there's my overlap. Now we've got to think about the third equation, and then at that point, then we'll see where that's going to end up at. All right, so let's go for it. Now we start off at negative 8, so we start off all the way down to the bottom there. All right, then we're going to go up from here, so it looks like it's up 2, 1 to the right, 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 and now we see where we're sort of crossing over things here. Up 2, 1 to the right, And then at that point, right after that, I'm done because I'm looking at my overlap, and I just figured out the two corners of my little overlap there. Now, can you keep on going? Absolutely. At this point, you're done. It is going to be a solid line. And let's use our test point again. Going back to the previous slide, 2x minus y less than or equal to 8. So testing 0, 0. The whole entire left-hand side becomes 0. Then it's a less than or equal to 8 comparison, and that is true. So we have that on our hands right there. All right, and the question is, where is the overlap there? Where is that little overlap that's shaded all 3 times? All right, and I kind of redid it here. I redid the graph again. It's this yellow section right here that I did. So now the question is, what are these corners there? And so there's in business and other places here, when we talk about minimum and maximum values, those things occur at the corners. That's why they want the corners here. It becomes application questions later on. So the graph itself is the answer, especially to make this little triangle a lot darker in. When you do that here, and then also label the corners here. So I got the first corner labeled as, looks like 2, 4. It's this one right here. Then we have the next one labeled as 5, 1, or sorry, 5, 2, which is this one here. And then the last one is 4, 0. So there it is. There's my graph and also my labeling of the corners themselves. All right, so now we get into nonlinear inequalities. How do we do nonlinear inequalities? Well, we're going to do them pretty much the same way. The graph and the shading will look a little different, but that's fine. All right, let's go for it here. So how to graph it? We do the same exact process. We're going to change this to an equal sign instead of inequality. And then we're going to think about this here. What kind of graph is this? Do you guys remember this from the library of functions all the way going back to chapter 2? If we had like this, x squared minus 2. Isn't that really just a parabola right here? Isn't x squared a parabola? So put it into pieces here. That's a parabola. And then that little minus 2 at the end, what that really means is, it just means it's shifted down 2 units. That's what it means right there. So it's a parabola that went down 2 units each time. All right, let's graph it then. So parabola, remember, goes through 0, 0. We're going to just shift it down 1, 2. Parabola also goes through 1, 1. So we're going to shift it down 1, 2 units. Let's see, a parabola also goes through 2, 4, because 4 is a square form of 2. Now we're just going to shift it down 2 units. How about back down to 2, 2? And let's see, 3, 9 would be the next one, except we're going to go down 2 units there. I think it should have been it. Let's see. See, made a little mistake here. 3 squared should have been at 9, so not this point. It should have been right here. My mistake there. So forget this point right there. I don't think I can clean it up right now. Let's see if I can white it out. Haha, I can white it out. That's cool. There. All right, the other side goes the other way. This one. So negative 2 squared would be a 4, but then we go down 2 units to a negative 2, 2. And 3 squared is a 9, and we're going to do the same thing here. We're going to change this up. My fault here. It should have been right there. That's 7, because 3 squared is 9. And we're going to take this off a little bit right there. Cool. All right, with that, let's go with the rest of it here. So graphing this here is solid or dashed line. It is a solid line coming down right there. Let me kind of pencil in those right there, so they don't look too weird over here. So there it is. Pencil that in. Okay, there it is. Arrows at the end. And now the question is a test point. Now, again, what's the easiest one to use? 0, 0, right? So notice there's kind of two different areas of the graph here, right? There's almost like this sort of inside the parabola area, and this whole outside of the parabola area here. So let's test it. Let's see what happens here. So 0, 0 comes in. That means the y becomes a 0. The x becomes a 0. So 0 squared is still 0. 0 minus 2 becomes this test right here. All right, is 0 less than or equal to negative 2? That is false. That is false. So we're not going to shade the inside of the parabola. What we're going to do is we're going to shade the outer rim of the parabola. So sort of looks like that right there. All right, and shading that out, there it is. There's a nonlinear inequality. All right, and to put it all together, how about this? How about a system of nonlinear inequalities? There's 3 of them. Now, when you say nonlinear, it just means that one of those inequalities is nonlinear. The rest of them could be linear. Could be a constant as well if need be. All right, I do see that all of them are being equated or compared to y. So let's do this here. Let's change it to equal signs. So how about y equals x squared plus 1? Y equals negative x plus 13. And then that's going to be a slope of negative 1 over 1, just for later purposes here. And y equals 4x plus 13. And then let's think about solid or dashed lines for these guys. This first one would be a solid line. Second one, less than or equal to, that would be a solid line as well. And the last one here is a dashed line right there, because it's a less than symbol only. All right, now let's start graphing these equations here now. So don't forget, it's the solid first one, solid second, and the dashed is the third inequality that we have. All right, so let's go for it here. Again, this is a parabola. Now it's up 1 unit here. So normal parabola goes down to 0, 0. Now it's going to go up 1 unit. Normal parabola goes through 1, 1. Now it's going to go up to 2, 1. Normal parabola goes through 2, 4. So we're going to go up 1 unit. And a normal parabola goes through 3, 9. And so if we go up 1 unit, now we're going through 3, 10. And remember, parabolas are symmetric, so that means the other side is exactly the same. And also it is a solid line, so coming around like this. Perfect. Let's do the test point. Back to the original inequality. We are testing 0, 0. And let's see, 0 is being compared to 0 squared plus 1. So is 0 greater than or equal to 1? I don't think so. So the comparison is this little dot here. The dot here is the outside of the parabola. Therefore, the shade is going to be inside the parabola. There it is. And again, extends up forever. I just have the shade up through the graph itself. All right, let's go to the next one here. Next one is a solid line. It starts at 13, so I'm actually have to go up 1. That's going to be 11, 12, 13 is going to be right there. A little bit above the shade, but I understand the shade does extend higher and higher. So, all right, looks like it's going to be right there. Now we have a slope that's negative 1 over 1, so 1 down, 1 to the right, 1 down, 1 to the right. And we can keep on going for a little while here to see if any of our dots actually do connect. And if they do connect, which is right there, perfect. We know exactly where that corner point is. Now for this problem, you don't need to do corners. You just need to graph the solution set here. All right, so at this point, I'm going to go, that's good enough for me right there. It's a solid line as well, so that's perfect. Now we got to do the test point. So test point, I'm going to still use 0, 0 as the test point. And back to the original inequality here. I'm comparing y, or 0, less than or equal to 13, because the negative x becomes 0 anyways. So is 0 less than or equal to 13? Absolutely. The shade then comes down towards the lower right. Again, where is the overlap? It's this little extra greenish sort of area right here. Right there. There's my overlap, and the last one here. 4x plus 13. Hey, this one also starts at 13, so that's cool. I know where my overlap is going to be between those 2 points, and we're going to go up 4. Oh boy, here we go. So I'm going to have to extend it even beyond the graph here. So I'm going to go 1, 2, 3, 4, and over 1. There's my little dot right there. All right, and then I'm going to go down. Let's see. So 1, 2, 3, 4 here. 1, 2, 3, 4 here, and voila. I see exactly where I want right there. And my line extends down, and the overlap is at this point right there. That's where my overlap is. And after that, I don't really care, because I see where my overlap is between all these different points right there. That's what I wanted to see. All right, test point. Here it is. Let's test this guy. Test point is 0, 0. Oh, sorry, kind of writing crooked there. Let's see, I'm comparing it to y, which is 0, less than 4x plus 13. So in this point, it's going to be comparing 0 to 13, and that is a true statement. So let me write it like this here. So if that's the case here, it's going to go this way. And the question really is, where's the overlap between all 3 points? And it's going to be right there. There's my overlap. I'm going to just kind of color it in a little darker there. It's this little piece right here. That's the part that now is all done right